What are some of the biggest misconceptions engineers might have about temporary works?
The first thing is that it's just invisible, right? Nobody hears about this in university, for sure.
Yeah.
Unless I think there are now 2 or 3 programs in the US that are starting to talk about temporary works design, temporary structures, kind of construction engineering in that aspect. But certainly when I was in school, you never heard about it. You were going to go design buildings, or you were going to go design bridges, or maybe do, something oil and gas, something related.
Temporary works and construction engineering represent one of the most creative sides of structural engineering, where innovation meets real-world constraints. Engineers in this field design structures that aren't meant to stand forever, but must perform flawlessly under complex temporary conditions. So, what misconceptions do engineers still have about this discipline, and what can we learn from those who've mastered it? In this episode, I'm joined by Ian Ebersole, PESE Technical Manager at Foothills Bridge. Ian has extensive experience in bridges, demolition, heavy civil, and power projects. We'll talk about overcoming design constraints, collaborating effectively across project teams, and how technology is reshaping the future of temporary works. If you're a practicing structural engineer or part of a project team navigating complex construction environments, this conversation will give you insights and inspiration to engineer smarter, safer, and more creative solutions. I also have an important announcement. We will be pausing the Structural Engineering Channel podcast for a while. With more than 170 episodes, I hope you've enjoyed the show and that it's supported you in your professional growth. Hosting this podcast has been an incredible experience for me, and I'm incredibly proud of the work that we've done. And I truly look forward to reconnecting with you all in the future. For the last time, for now, I'm your host, Matt Picardle, and this is the Structural Engineering Channel. Ian, can you tell our listeners about yourself and what led you to focus on temporary works and construction engineering?
Yeah. So I'm Ian Ebersole. I've been an engineer for 15 years or so out of school now. Temporary works, honestly, just stumbled into it. My wife is also an engineer. She was in construction. She had a career with we'll say a big yellow contractor that likes to move their people around a lot. Had a great career with them, a great experience there. And so we moved a lot early in our career, and I got to try a whole bunch of things. I was in geotech for a little while, utilities, power. But one of the places we moved, they were kind of the only game in town. So I joined the big GC, and I was in their temporary structures, temporary works group, supporting all the big civil projects that they were building. And just fell in love with it, stuck with it, got to keep moving a little bit, but have stayed with the temporary work side for now the last 10 or 12 years, somewhere in that range. Yeah, supporting contractors as they're executing these massive projects, a lot of times on the bridge side, but also heavy civil, other types of infrastructure projects, and then every once in a while dabbling into something a little bit less common for us on the building side or a smaller project like that.
Yeah, what are some of the common projects, as I say, for someone that isn't familiar with construction or temporary works engineering? Give a quick example of a problem that you solve, or maybe a typical project.
Sure. It's surprising how many projects really can use some attention from a temporary works focused individual. So I now work for a company called Foothills Bridge, and as you might guess, we tend to work a lot on bridges, particularly doing bridge demolition projects. And so oftentimes we are tasked with an existing bridge that the state has decided is too small or is no longer structurally sufficient to carry traffic. They've got some concern about deterioration, or just the fact that, bridges have stayed the same, but cars and vehicles have gotten a lot heavier over the years. And so we reverse analyze that and think about, okay, how can we manage to remove that in a safe and effective manner? A lot of times that means putting a overly large piece of construction equipment out on this bridge that the state has just decided they don't like passenger vehicles riding on anymore. And so we do a lot of design to think about, can we strengthen it? Can we just be very particular about how we put that construction equipment on the bridge? Do we need to add temporary supports underneath the bridge? Can we do all of the work from beside the bridge, get some access out into the river or out over the waterway, whatever that bridge is crossing, and do everything from the side so that we don't have to be up on the structure at all?
Wow. Yeah. Even just bridges, if they're out in the water, how you even gonna work on it, huh?
Access is so commonly, the first and the biggest challenge.
Yeah, it's interesting. What are some of the biggest misconceptions engineers might have about temporary works?
The first thing is that it's just invisible, right? Nobody hears about this in university for sure.
Yeah,
Unless I think there are now 2 or 3 programs in the US that are starting to talk about temporary works design, temporary structures, kind of construction engineering in that aspect. But certainly when I was in school, you never heard about it. You were going to go design buildings, or you were going to go design bridges, or maybe do, something oil and gas, something related along those lines. So a lot of permanent designers either don't know it exists, or it's just in the back of their mind of that's somebody else's problem, that I'm going to design the final product and someone else will figure out how to get it there. Well, that's us. That's temporary works designers, temporary works engineers.
that stuff needs engineering too. It's something. I know when I first started, it was like temporary engineers. Well, it had engineers. So then when I learned about that, it's like, oh, there's another engineer that in order to make this project happen, we're gonna need. There's another set of engineers that tackles this problem that we're not dealing with. We're kind of dealing with in the works that I do. It's kind of the final product. But yeah, in order to build that, there's all this other engineering that goes into just having access, right?
Yeah, it's kind of like, people thought about, hey, I'm going to go design some consumer electronic product. And then about 10 or 15 years ago, everyone kind of became aware that there were people who were designing the box that the product came in, and kind of the experience of opening that box and what that felt like when for someone to get a electronic device, and you saw this attention towards the packaging and how that all went together. In some ways, we're kind of that person who's designing that experience of actually unveiling the final product that somebody else, the original designer, has worked on.
Yeah, very cool.
Transform your technical experts into impactful leaders with EMI's Engineering Leadership Accelerator. Tailored for AEC professionals, this program enhances communication, delegation, and decision-making skills. Flexible, interactive, and designed to fit your team's schedule. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on corporate training.
What about some of the design challenges that arise when working on demolition, or maybe some of these sites that are heavy, that are harder to access?
Yeah. It's all over the board. And that's one of the things I love about temporary works work, is that the variety is just unending. There's always a new problem to solve. There's always some different variation. It can be challenging in that we very rarely have a great example to reference from the past. Oftentimes we're pulling bits and pieces from things that we've done in previous projects. But yeah, access, like I said, is that first challenge of how can we get to the work and how can we then perform the work. It's one of those things that, especially for a young engineer, someone doing temporary works for the first time, can be very overwhelming and can be very challenging to navigate the idea of how we need to collaborate with the contractor, whoever's going to be actually performing this work, their project manager, of course, but the superintendent, the foreman, and even down to the individual crew members, because there's so much that as a temporary works engineer, I can't know about that operation and their process. It's just too much information, and every crew has their own tendencies, their own preferences, their own limitations about what they can and can't do. And so a lot of times that's really the first and the hardest step, is figuring out what's a plan that can meet the needs of the contractor to accomplish the work, but that we can also fit into a structural system, a structural analysis that checks all the boxes that we can put on paper and put our stamp on and say with confidence, yes, this meets the standard of care. This is going to be acceptable within all the parameters of structural engineering that all structural engineers would practice.
And I had a follow-up question about some of the 'Cause you're mentioning temporary works, but also demolition. When I'm thinking of demolition, I'm thinking either a big wrecking ball or I don't know, explosives. Like,
Mhm.
what do you what's the reality of that in terms of coordinating those efforts?
There are times when wrecking balls and explosives work great. They're effective. They are very quick. They get the structure down into a material that you can process further very readily. But there are times when that doesn't work, because in the bridge world we've built a new bridge, the replacement bridge. Usually you do that first, but we wanted to keep that on a very close alignment. We didn't want to have to shift the roadway over half a mile to be able to do this new bridge. So you have a brand new bridge, oftentimes inches. When we did the Bay Bridge in San Francisco, the replacement span was literally inches away from the span that we were demolishing. And so obviously there's concerns that in your demolition operation, you don't want to undo any of the hard work you've just done to get this new replacement bridge up and open to the public. So you have that, you have environmental considerations. If this is crossing some waterway, some environmentally sensitive area, even just a wetland, oftentimes then what we are able to do at ground level, or what is debris allowed to drop and then be retrieved along the Mississippi River. A lot of times that's fine, that you're allowed to use explosives, drop the span into the river, and then just dredge it back out. And you'll do scans to make sure you got it all, but it's okay for it to drop in and then be pulled out. Other locations are much more careful about that and say, no, nothing should ever touch the water below. And so that really changes your means and methods.
Yeah, it's essentially those are options that you can take, but it heavily depends on probably the jurisdiction or what the environmental factors are. And then I guess that's part of your job, right? In terms of what is the best solution for what we're trying to accomplish here.
Yeah, how can we help navigate all these different risks? Each of these operations carries risk with it, but they're different risks, and the risks impact different parties in different ways. So a project that is in a very industrial or very open rural area is going to have some risks and some stakeholders, some people who are concerned from the community for different reasons, than a project that's in a very tight urban environment.
What about codes and standards and safety standards? How do those fit in? Because I know in typical building design, there's building codes, but what about, yeah, construction demolition? Or how do those look like?
Yeah, so that's a great question, because it is one of the most interesting and most unique parts of being a temporary works engineer. We certainly draw from and reference from permanent design building codes, ASCE 7, AASHTO, IBC, ACI 318, all of the standard set that you would study in university and for your licensure exams. But very rarely do those codes either explicitly or even implicitly include the temporary works engineering that we're doing. There are a couple of codes that build from those and shed some light on the temporary work side, like ASCE 37 is the essentially the sister volume to ASCE 7 that says when you're talking about a structure that's under construction or demolition, here's how you would adjust or consider the environmental loads that ASCE 7 has put out and put in front of you. There are a couple of documents like that, but it's really pretty rare. So oftentimes we are referencing from code documents to build a first principles understanding of the problem, but we're not necessarily following any one code to the letter of the law because it doesn't fully apply, or it has some limitations that don't really reflect the construction situation. It's challenging because the flip side of that is that we do have professional obligation and a standard of care to uphold, and it's not that we are allowed to just go out and be cowboys and do whatever we want that we think will stand up at the end of the day. Our insurance companies wouldn't stand for that. Our clients wouldn't stand for that. Owners who review our work wouldn't stand for that. And honestly, we're not interested in it because there's plenty of risk inherent in what we do. We don't need to add any by being flippant about the structural calculations.
Yeah.
There's actually a group. I was just in New York last week meeting with this group from ASCE. The Construction Institute of ASCE has a working group for temporary works. The Temporary Works Committee actually is what it's called. And there were about 40 of us in person, and another 20 or so people joined us for the day virtually, talking about these issues of, okay, where do we follow the codes? Where do the codes give us the information that we need to perform these designs and to create safe and effective structural solutions to these temporary works challenges? Where are there gaps? What are some reasonable ways to address those gaps, whether it's borrowing from some other standard? Sometimes I'll borrow from something out of Eurocode or some other standard that doesn't apply in a contractual sense, but it has some guidance that's useful. And where do we just need to start solidifying and publishing information of our own? So this group has come out with some documents about the best practices for getting a rebar cage into place and stabilizing that until the concrete can be placed around it. Best practices for demolishing bridges, best practices for considering wind loads on these temporary structures that don't really fit into the provisions of ASCE 7. And so we're starting to publish and provide some documentation and just kind of come to industry consensus on what's the right way to handle these situations that aren't spelled out in a code.
Yeah, I think that's the key word, or it's not spelled out in the code yet for these unique situations that involves temporary construction engineering. I'm sure there's a lot of issues where, oh, it's not in the code and it's a unique situation to our project. We have to use some engineering judgment to make sure this works. But also, hey guys, the code committee, we've run into this problem a lot. There's nothing in the code. What can we do to maybe help clarify it for other engineers that are running into the same thing?
Exactly, because we don't want to end up with 4 plausible but entirely divergent solutions on things, and that's really challenging for a young engineer to navigate in particular. How do I know who to believe in and where the actual threshold of a effective and safe design is going to be? So if we can come to some consensus and provide some guidance on, hey, here's some things that have worked in the past, here's the basis behind them, and here's our recommendation of how to implement this as a best practice, it really helps the whole stack of people who are involved in this sort of situation.
Yeah. And from your experience, when working with contractors, designers, other engineers, how crucial is that collaboration? And maybe give me an example of when it worked really well and how crucial it is for the team success.
Yeah, so I mentioned how critical it is to really talk to the contractor and really a breadth of people inside the contractor's team early on. No temporary works engineer is successful working in a silo. You can't say, all right, Ian, I need this cofferdam and I need it in 2 months and go. There's constant communication back and forth on that side. And that's really just vital. There's no way to come up with an effective solution without it.
I was trying to imagine the partnership, let's say with the contractor, and you guys are going to demolish a bridge. I'm imagining there's always is there constant feedback from the contractor on, no, this isn't going to work, or we got to do it some other way? Because you're coming up with engineering solutions, but they're the ones that are like, do we even have that equipment? Is it constant? How's that look like?
Oh, right. In our best scenarios, then there are calls very early on and very often as we hash through the design. We'll oftentimes iterate through 4 to 6 different possibilities, different operations, different combinations of equipment before we even come close to anything that we would put down in a stamped submittal. Just because, yeah, lots of ideas. There are lots of ways to solve these problems, but it's a question of what is going to be effective for the contractor, what fits their capabilities and their skill sets, what fits the equipment that they have available or that they can achieve, and then how does that fit into their construction schedule. A lot of times as an engineer, I don't have visibility into their exact costs or their exact schedule, what all of their constraints are. So we want to be picking at that and trying to understand that as best we can, but also realizing that at the end of the day, we're just going to need to put several different options in front of the contractor and their team and keep fleshing that out until we come to consensus on one that feels like it's going to work. And then, of course, we go out in the field. We oftentimes are standing right there on the side of the bridge or right next to them as they're performing the operation for the first time. And usually we come across a couple of things that didn't go the way that we expected, or they're growing a little slow, that we think we can improve the production rates. And we'll go back to the drawing board and say, okay, we tried it. Let's see what we can improve. Let's see how we can make this even more effective for you as you perform the rest of the work.
It's pretty much working shoulder to shoulder with contractors, even out in the field as well.
Yeah, and I love that side. I love that I get to go out, especially in California. California, as part of the state standard specs, requires that when we are touching one of their bridges to remove it, a PE needs to be standing right there observing it, to communicate the plan and make sure that things are going well. But it also gives us an opportunity. I'm talking to a operator for an excavator and saying, hey, when you chip on the concrete over here and you chip on the concrete over here, what's the difference there? How does it feel to you? Where do you feel like you're able to be productive and really munch that concrete up versus where you're dropping chunks that are probably bigger than you feel comfortable with? All these little adjustments, all these little tweaks that as an engineer I can take back and implement in the next revision of that plan or my next project. So there's this constant improvement, constant feedback cycle for us to just get better and better at what we do.
So is there a lot of, maybe not a lot, but it seems like you're out there when they're actually doing the demolition or the work. It's not just a structural observation that maybe someone might do for a site visit, but it seems like it's more constant oversight over the process of demolition.
And that varies. It varies by the complexity of the project and the contractor's capability, their comfort level with doing the work, but also, what their staffing is like. If they have a team that feels like they are able to do that monitoring and then just report back to us, versus when a contractor's a little bit shorthanded, they might be that much more interested to have us directly on site and able to interface with their crews. So it's all over the board, but yeah, it's definitely something that happens a lot more on the temp work side than in a permanent design office.
What lessons have you learned from working on some of these complex bridge projects that maybe from that a younger engineer might be able to benefit from?
Certainly what we were just talking about is one, just the value of talking to the crews who are actually implementing it and figuring out what works well for them and where are their pain points. I remember one of my early projects at the Bay Bridge, we were taking down the old truss structure, and there were a lot of discussions about, okay, we need to get to this bolt, we need to get to this rivet. What does the access look like, and how can we actually reach through this handhole and up into the truss to get to the backside? Well, I have skinny little arms, but you put an iron worker up in that same scenario with his fall protection equipment and his respirator because of the lead paint and all these sorts of things, and it becomes quite a bit more challenging.
Yeah.
So, but on the other hand, they can actually get a bolt snug tight, and I have no chance of that. So,
And how do you communicate these? Because it's not, I'm imagining there's, for buildings, there's structural plans, but for temporary works, it seems like, I don't, maybe it's almost 4D where, you need a time scale, how everything's going to get constructed, the sequencing. How do you communicate that to the project team in terms of this is what your design looks like, but how do you communicate that to the entire team? Maybe I'm thinking sketches, visualizations, 3D models, or yeah,
all of the above.
How does that go about?
Yeah, all of the above for sure. I was talking to a friend who does residential design, and he was just flabbergasted that I'm putting out drawing sets that are 80 sheets long for these projects, because so many of the details require some sort of sketch, some sort of way to communicate, okay, this is how these pieces are going to fit together, and here's the sequence of how they need to be put in place, because there's only really one or two ways to get these pieces all into place correctly. The geometry constraints, just the ability to get to all the different pieces that you need. We have actually, in some ways, maybe led a little bit in creating 3D visualization sketches and animations. We've actually found that in a lot of cases, putting together a short animation clip of these different pieces coming together is a great way to communicate, or these pieces coming apart. So just helps to really communicate effectively with everybody. The truth is that if I wrote the entire plan out in prose form and paragraphs of text, that it doesn't get read. It really doesn't. So we're always looking for creative ways to show a challenging geometry, a challenging little detail in a couple of different ways so that the vital information there gets passed to the project manager, the project controls team, who needs to be thinking about the cost of it and what resources they need to have available, the superintendent, who needs to understand what his operation looks like at the end of the day, and the guy who's literally chipping rivets, putting in bolts, cutting something with a torch, whatever that might be.
Do you call those demolition plans, or what type of plans are those? Those seem like really interesting in terms of the construction sequencing.
Sure, it could be a bridge removal or bridge demolition plan. It could be an erection plan on the construction side. I talk a lot about the demolition side. It gives us the good photos, great photo operations, pretty fun stuff. But we also do construction engineering, helping get the new bridge into place or whatever permanent structure. We've been doing a lot of waterway work recently, and how we can help create these dams and locks and navigable waterways. So same kind of thing there. And plans of all different varieties, all different types. Our number one rule on that is whatever communicates well, whatever achieves the goal for the contractor is what we do. So we try not to have a lot of rigid rules and a CAD standard policy that's, here are your layers, here are your line types, XYZ is what you're going to do. There's a lot of flexibility, and every scenario is a little bit different. So we're just shooting for that end product that gets everybody on the same page, helps everyone understand what the objective is and how they can be a part of achieving that safely.
That's awesome. Looking ahead, what about emerging trends, technologies? What do you see shaping the future of temporary works and construction engineering?
Sure. I mean, we'll stay on the plan side a little bit in that we started adapting this a long time ago, but we've certainly accelerated it recently, is the idea of 3D models and sharing that. We're finding that more and more partners in the industry are interested in becoming familiar with the different tools. We tend to honestly rely on Google SketchUp. I guess it's Trimble SketchUp now. We'll have to edit that. We rely on Trimble SketchUp because it has a very flat learning curve, a very easy learning curve to just start putting models together. And so it's a really easy way for us to collaborate with a contractor who probably doesn't have a dedicated drafter or a dedicated visualization team themselves. Maybe the bigger ones do, but those guys are often tied up on other challenges, other projects.
Yeah.
So easy for a field engineer to pick up and say, you know what, here's what I'm seeing right now in the field. Here's the geometry challenge that I have to work out. And we can collaborate back and forth on that really quickly and solve these very geometrically constrained problems that we have.
Yeah, so maybe like a Teams meeting or a in-person meeting about going through a SketchUp model. So, hey, here's how we're trying to access it. Here's what we're trying to do, instead of just, what are you seeing out in the field? Maybe you sketch it up for me. Or it seems like a 3D model would be the way to go on some of these complex geometries that you guys are seeing.
Yeah, there are projects where it's helpful and there are projects where it's really vital. And it's fun that SketchUp actually has the capability to go as far as we want. We've done full plan sets out of SketchUp that really look very crisp, and you'd hardly know that it's that. People would confuse it with a Revit plan or a plan from some other software really readily. But it helps you stay out of the trap of, I think, some things that have happened with level of detail in BIM, where a BIM model can oftentimes be mismatched with the level of detail that is useful for it. Either it's challenging to get the full level of detail into the model that you need to really make the decisions that you think you're making, or on the opposite side, the investment in getting that level of detail is much more than the return that you get from it on that coordination and collaboration side.
Yeah, finding the right level of detail versus too little or too much. Because I've seen both.
Sure.
What's one final piece of advice, Ian, that you can share with our structural engineers about embracing creativity and practicality in a temporary works design?
It's one of the great things about temporary works. There's always pressure, no matter what kind of structural engineering you're in, to be efficient, to optimize, to solve the problem as best we can. And one of the fun things about the temporary work side is that when we're talking about the scale of challenges that we're facing, especially when something unexpected comes up, if the alternative is that a contractor's crew and equipment is sitting idle at $20,000 a day, $50,000 a day, and unable to do the work to complete their contract, that's even before we talk about something like liquidated damages. It means that the realm of possibilities and the options to solve that problem it expands. There are very few things that are too crazy to consider when we're talking about that sort of a challenge to face and to solve. So yeah, embrace that creativity, embrace the weird solutions. The math has to check out in the end, but there's lots of ways to get a solution that checks out and that you can put your stamp on.
Awesome. Thanks so much, Ian.
Of course. Thanks, Matt.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.